everyone. My name is Susana Viegas, and I'm presenting some of the results of the project developed on battery recycling. This project was developed in the scope of HBM4U, a European project focused on the use of biomonitoring to evaluate exposure on different occupational settings. So I will present the HBM4U occupational studies, the goals of those studies, the studies that were developed, and explain a little and present the kind of occupational settings that were considered and our main achievements when developing these projects. So we aim to answer to these questions. What is the current exposure of workers to the HBM4U priority compounds in specific activities? So in the scope of the HBM4U project, it were identified specific chemicals that were considered a priority to know more about the exposure. We also want to know how HBM data can support current policy actions to manage occupational exposure to hazard substance, and also what is the role of biomonitoring as an exposure and risk management tool in occupational safety and health context. So these were our goals when we developed the occupational studies. The studies developed were three. One of those was the HBM4U chromate studies involving four countries in the EU. And the idea was focused on the use of chromates in surface treatment and welding. We also studied PFAS exposure in this occupational setting. As I mentioned before, we study e-waste. So we try to identify what was the exposure to several priority compounds in this setting, and different kinds of e-waste were considered. We also developed a study focused on exposure to diisocyanates, focusing mainly on MDE and HDE. And it was on construction and manufacture and repair of motor vehicles. We had important achievements. One of those was the harmonized approaches for the collection of the samples and contextual information, and this can be reproducible for use in other studies. So in all the member states, partners that were involved in the three occupational studies all follow the same SOPs, trying to collect and analyze the samples in a similar way to allow comparison of data. So we had some main conclusions for the e-waste study. So we conclude that the battery recycling workers with high exposure to lead and above the new limit that was defined for the EU. We also had exposure to other hazard metals at high levels, such as cadmium. We also found exposure to organic compounds such as phthalates and others, and these mainly was found on biomonitoring data, but also in the settled dust collected in several workplaces. And of course, we were able to conclude that there is a need for additional risk management measures in this specific sector. And we also were able to conclude that biomonitoring is the best method for exposure assessment and health surveillance of these workers and should be promoted the use in this kind of sectors. So some background concerning the e-waste, what is it and how we address the e-waste sector. So we create these three group of e-waste: white goods such as refrigerator, washing machines and microwaves; brown goods such as television, radio, computers and cell phones; and also components. And in this case, we include the batteries, the plastic casings and cables. We made these three groups because mainly we had companies dealing with different types of e-waste. And so we want to do some comparisons between these three waste streams in the scope of e-waste. We want to present the data in a specific manner, and that was the way to address this. Of course, e-waste was chosen mainly because in the scope of the circular economy, that is something that is being very much promoted in the EU. We expect that the waste management sector and also the e-waste sector will increase it is already increasing and it will increase also in the future. So the general objective of this e-waste study was to study the internal exposure of workers processing e-waste using human biomonitoring approach, including also external exposure measurements. As I mentioned before, we also consider some industrial hygiene samples. We also collect contextual data, and we also consider some effect biomarkers to allow the identification of opportunities for further improvements of occupational health practice. A specific objective of this study was to identify and evaluate the complementarity of different exposure assessment tools for detailed occupational exposure assessment. So the study design, it was a cross-sectional study. 8 countries collected environmental and biomonitoring samples. Of course, we had ethical approval and informed consent from all companies and workers. The data collection performed in a harmonized way, resulting in comparable data for the participating countries. As I mentioned before, this was an important achievement. We defined standard operating procedures and we all tried to follow it as much as possible to allow this European study to have comparable data. And the samples collection were made according to the protocol described in a previous publication from 2021. And indeed, in that paper, it was described all the procedures that we were taking during the fieldwork. So these were the biomarkers of exposure and effect that we consider. Also the kind of biological metrics that were considered for each biomarker, and also the moment of sampling for each biomarker. So we decide to present here or try to give more detailed information on battery recycling company that was included in this study, and to compare the results of this company with other e-waste companies. So in this case, the lead battery recycling company we were able to include and engage in the study 23 workers. The workplaces that were considered were crushing, sieving, extraction, logistics, maintenance, and also quality and support. Here, a brief description of the different steps of the process of e-waste management, in this case for the lead battery. So concerning mercury in urine, we can see here the results of batteries pre-shift and post-shift. We can see there is a difference between the two moments of sampling. We can see that in the case of mercury, the workers from the brown goods waste have higher values of mercury. So battery is not the kind of e-waste where workers have high exposure to mercury. Concerning cadmium and lead in urine, here it's different, as you can see. Here, batteries workers have the higher results. So for cadmium and also for lead. And here we are talking in urine samples. And we can see that, particularly for lead, there is a big difference, statistical difference from the other kind of e-waste. In blood, we can also see this difference. So battery workers still with the the high values for cadmium and for lead with statistical difference from when comparing with the workers from the other e-waste companies, and also, of course, when comparing with the control results. So if we consider the reference values or the limit values that we have in the EU, the one that was proposed recently, and it is already included in the directive, is this one, the lowest one. And we can see that indeed most of the battery workers have values higher than that reference value or limit value. So we need indeed to tackle this issue and implement additional risk management measures at that company. The workers had already PPE and also RPE when developed their tasks. Of course, we identified that there was some issues regarding the use of PPE, mainly RPE, because in some cases it was possible to observe that RPE was contaminated. It was not clean or substitute with the frequency that it should be, and probably also supports this kind of results and help to explain these results. And there was also some limitations on some of the risk management measures, mainly in contention, ventilation, and so on. So a lot to do in this company. So main conclusions now for the battery workers. Now the pre and post shift pattern suggests work-related exposure to chromium, mercury, and lead. So the difference between the pre-shift and post-shift samples shows that the workers are exposed to these three chemicals during their work shift. And mainly the blood lead exposures are in range of values that show that there is a lot of measures that have to be implemented as additional measures to protect workers' health. So what are our future actions? We plan to further analyze our data and to use industrial hygiene measurements and questionnaire data to support the interpretation of our HPM findings. Some of our first manuscripts from HPM4U concerning e-waste were already published. The other ones are being prepared now. And concerning the ongoing project PARC, we are now focused on two waste streams. One of those is continue the e-waste, but we include another waste stream that is the plastic waste stream. We are now in the phase of collecting samples. We made all the adaptations to the SOPs to apply to this new project, and well, we are in full speed collecting the samples in several member states and in several companies. So we aim to have data in the end of 2025 and then start analyzing the data. During that period, we intend to continue to publish our data concerning the HPM4U project. So some acknowledgements, mainly to the participating companies and workers, to all the occupational studies that were developed in the scope of HPM4U. And thank you mainly to these colleagues that prepare some of the data that I present here, and also to Paul Shippers that present some of these slides in the conference of ESPN 2023 that I use and adapt to prepare this presentation. Thank you so much for your attention.